Well, thank you very much for the invitation to come and speak to you here. I should probably just slightly clarify the difference here in my kind of affiliation, if you like. I am a civil servant at the Department of Health, but for the last 6 months or so, and all throughout this project, I've been seconded and working quite closely with Genomics England. So today I thought I'd call myself Genomics England, but I'm there as part of the support team for this endeavour. And I think what I just would like to do is, and I find it hard to follow on from those previous fantastic talks, is to give a bit of background about the genesis of this project and the sort of structure of the project, and possibly slightly less about some of the issues around ethics and the market and so on. And I was just thinking, I don't know if Mike is here, but actually a lot of these points were raised by Mike in the very early days, and so it's very nice that Mike's actually being here to actually help solve some of these questions about what the framework should be like. But the project, the 100,000 Genomes project, is one of those Olympic legacy projects. I think it's best to describe it. It was a project that, an idea that was formed as part of the big international gatherings and summits that happened around the Olympics in 2012. It was Genomics England itself was announced by our Secretary of State for Health in a speech on the 65th anniversary, where he tried to make the connection between the historical sort of antecedents of the NHS being a really fundamental driver of innovation, and then how to take this forward into the next phase of medicine. So these are sort of quite important backdrops. But I think it's also worth, in the context of this meeting and in the speakers this morning, actually stressing that this was an announcement made as part of the government's life sciences strategy, which is part of the wider growth plan in the coalition government following the big recession in 2008. So we really have to sort of recognise that this project, as well as being part of the Olympic legacy, is also part of our strategy to ensure that the life science industry continues to flourish in the UK. And I'm sure you probably can't read all of these rather dodgy excerpts from the strategy, but I will be covering them later. But really, basically, it says here the government's three priorities are to harness the potential of the NHS for patient care, to maximise the opportunities for research and translation of genomics, and to accrue economic benefits for the UK, and in particular to start us to see if we can become one of the countries that really is in the lead about some of the bioinformatics companies that we think will need be developed, as Gil was referring to earlier. And I think I'll leave the rest for you to read on the screen. But I think really what it is a combination of things in this project that pull against each other in some quite interesting ways, and I'll talk about that later. But once, I think, I'll be honest with you, as being somebody who was quite intimately associated with this, once the announcement was made by the Prime Minister in December 2012, we were all left in, I feel honest with you, a little bit of uncertainty about quite the best way forward, because it was such a massive thing that had been announced. My parallel, if you like, showing my age a bit, is that I think we all felt like NASA must have felt when President Kennedy said within a decade we're going to land a man on the moon, and they hadn't even put a man in orbit yet. And I think we felt the same, that the NHS hadn't really got behind whole genome sequencing, and we were going to deliver 100,000 whole genomes in 3 to 5 years through the NHS. And I think, so what we initially did, established by Dame Sally Davis, who was then our Chief Scientific Advisor, was to establish a strategic priorities working group, which really looked to focus on what the areas should be that we should focus on. And it also, in parallel with that, had a group on how the data should be managed and stored, which was chaired by Dame Janet Thornton, and a group on the ethical principles, which was chaired by Professor Mike Parker. So the three working groups were established immediately, and they did a fantastic job of reporting back by Easter 2013. In relation to diseases, the areas of focus, the recommendations were for rare diseases, a subset of the common cancers, and for infections. And I think infections I'll probably leave to one side, because that's a sort of separate project, because really when we're talking about sequencing infections, we're talking about sequencing the pathogens. Tempting as it may be, I don't think we would have got any points for sequencing 100,000 pathogen genomes. I think that would be a fairly minimal challenge, really. But so what we really wanted to do was focus on those areas where we would have the greatest impact on patient health. And just a bit about rare diseases, because I think this is sometimes one of the worst names for what is really a very common set of conditions in terms of their impact on patient health and on the NHS services. there are something like 1 in 17 patients who suffer from a rare disease at one point in their life. That's around 3.5 million people in the country. Many of them haven't had a diagnosis. They really are in the system still kind of what you might call rattling around from one consultant to another trying to get a better diagnosis. There are 6,000 different diseases, so hence it's very difficult to really have anyone who's specialist in any particular one. Roughly 80% of them are genetic in origin, and 75% of them affect children below the age of 5. And I think, and sadly, 30% of those children would die before their 5th birthday. So this is quite a major impact on the health service, on patients, on the children themselves, if you like, on other adult patients, and also on their families. And it's a really kind of fundamental focus for us in this project. And just to explain a little bit about why a diagnosis is so important, it's really just giving all of those answers to all of these questions patients have. How did I get this? What's going to happen to me next? What can you do for me, doc? And is there anybody else I can talk to about their experiences? And I think this has been tremendously powerful to hear this from some of the patient groups that have been mentioned already, such as Rare Diseases UK and Genetic Alliance UK. And I think one of the other key points that is worth emphasising is that it's often important for other members of the family to know whether they're at risk. And it's often really important, particularly in the children's cases, to understand whether parents are at risk of passing the same illness on to future pregnancies. And sometimes this question about is it safe to have another child, is it my fault, and so on, are really quite important drivers for parents to understand a diagnosis. And I probably shouldn't say this, but I think it's worth bearing in mind that this is exactly the experience that Mr. Cameron would have had with his child, Ivan, who was born with a rare disease. And both him and his wife, were then very uncertain as to what the options should be for the rest of their plan to start a family. So I think Mr. Cameron comes with a very strong personal experience of what this project really could do for patients. So this is just an example of, I quite like this example, not least because it was one of the first examples that came from the pilots of the 100,000 genome studies. I take no credit for any of this, but I think it's, from a policy perspective, it's a very interesting example. This is one of the Newcastle Bioresource patients, Leslie Hadley, who had suffered from kidney disease all his life. I think he's had at least one transplant. He's been on dialysis an awful lot. There were signs that his daughter, who's on the right, was suffering from the same symptoms, and potentially they were concerned about his granddaughter in the middle who might have the symptoms. By doing a whole genome sequence, it was possible to identify a mutation in the INF2 gene. That gave knowledge about how to potentially prevent the worst effects of this in his daughter, who can now have her blood pressure more effectively controlled by a drug that wouldn't normally be given at such a stage or in such a dose, I understand. So what you have there, I think, is quite interesting, because you have, and also they discovered that I think that the granddaughter in the middle hasn't inherited the mutation, so she's not at risk. So what you really have there is this sense of, I think, a number of things that are quite interesting for the healthcare service to understand. Preventing ill health in the daughter, whose name escapes me now, we would save an awful lot of heartache for her, an awful lot of cost for the NHS, with a fairly cheap drug that's being, in effect, repurposed or given in a slightly more assertive way. And also then knowing that this other family member is not at risk and does not need to be worried about their risk of kidney disease. So all of those things are what we really tend to refer to as a kind of personalised medicine or precision medicine. And they don't involve some heroic discoveries of a drug that the NHS won't be able to afford to buy. And these are sort of different parameters around how genomics might benefit the NHS, which I think are encapsulated in this story, which was one of the first to come out of the project. We've had more since then, sadly not as many as I think we'd all like, but there have been now some diagnoses in children from the Great Ormond Street pilot study. I think one of these young ladies has also managed to benefit from a more a modified diet, which will address the epilepsy symptoms that she's been suffering from. And again, that's by understanding more about the causes of her complex disorder. And I think one of the important points made by one of the mothers of these girls is that they now know that these are sporadic mutations, a de novo mutation, and there's no risk of a future pregnancy being affected, or no greater risk of a future pregnancy being affected. So for one lady who I think was in her late 30s, it's very good news, so she can now think about having more children. We're also sequencing cancer. That's a very important element of the project. It's one that's taking time to really get going. But there it's because, we all probably understand that cancers are effectively a genetic disease. There's a combination of the, if you like, the mutations that you will have been born with that give you a slightly higher risk, but also the mutations that happen in tumour cells and the instability that happens in tumour cells, which can really give an idea of the sorts of targets that modern drugs might be able to tackle the cancer, but also some of the risks that might be inherent in having radiotherapy or any other intervention. So cancer is a really important disease. It's also really challenging because, of course, it's all about speed there. It's all about getting the diagnosis back in time. So I think it's really important to let the Cancer Project get up to speed and not overstate the benefits at this stage. So coming on to the project overall, having given a little bit about some of the reasons behind it, I've sort of touched on the benefits to NHS patients. I think the other parts of this project are equally important. We want to create a programme based on consent, to be ethical, transparent, and to be absolutely beyond reproach in terms of how patients' data is being used and accessed. So it's being really open and transparent about that. And I think one of the touchstones of this whole project is that we must maintain public trust and confidence. That's patient trust and the wider public, which I'll come on to later. It's a research resource, very much along the lines that Sir Rory Collins mentioned. It's actually about providing access for research to make new discoveries and medical insights. And it's also there to support development of an industry. And that's not just in allowing access by companies who would like to use the data. It's actually about how we actually deliver the project. It's how we get small companies engaged in the project to harness their sort of innovative potential. And as you can probably imagine, in those 4 aims, there's quite a lot of tension in those aims. You have to be careful. One has to be careful to make sure that doing something which is supportive of a nascent genomics industry does not harm public trust and confidence, or doing something which is good for research access doesn't go against the consent that patients have gotten. So these are sort of like in a creative tension. We're trying to pull together against each other all the time. So here are the main features of the project. I just will run through these very quickly, but we can talk about them later if you wish. The first one I think I'd just like to touch on is that the project's being delivered by what we call a special purpose vehicle called Genomics England. Technically it's Genomics England Limited, but we tend not to focus on the limited. But it is a company. It's a company because a company is very quick to set up. A company is widely understood by all sorts of international legal partners as being a particular thing. Special Health Authority was another option, but Special Health Authorities are barely understood in the Department of Health, let alone in wider international spheres. We could have set it up as an arm's length body, but that would have meant legislation. That would have taken a long time. So we have a company. It's a company 100% owned by the Secretary of State for Health, and it's not a company that we're intending to do anything more than just deliver this project. It's not a kind of Trojan horse for any other thing. And I suspect we'll have to keep saying that over and over again, but it is one of the most fundamental points there. Are we going to sequence 100,000 genomes? It's going to be a project to transform the NHS. Just a little bit on infections. We are working on infections with the Public Health England, who are doing a lot of work to roll out whole genome sequencing for pathogens, particularly focusing on tuberculosis at the starters. And I think it's also very important that we might want to include patients who suffer severe reactions to quite common infections. Severe sepsis would be a good example of a rare condition that we might want to include. But again, it's very easy. It's very hard to get this working in practice because it's such a time-critical process. So we haven't yet done that. Consent is at the base of everything that we do. But this is consent also that allows not just the sequencing and the analysis and interpretation and feedback, but also, as we heard with the UK Biobank, long-term, longitudinal follow-up. The ability to link patient records, HES data and so on to the genome data is absolutely fundamental to this project and builds on some of those strengths that we have in the UK. The project is being delivered very much with the NHS, something I hadn't really touched on yet. This is a project that is at its heart based in the NHS. We have a brand new concept, which Oxford is a good example of, genomic medicine centres, which are a kind of hub with a variety of spokes in other centres that bring together the current expertise in genomics plus all the other required research resources, biobanks and so on into something called a Genomics Medicine Centre, commissioned by the NHS England to drive genomics into the NHS healthcare. We're not going to do quite the same thing, I think, as the UK Biobank, in that all of the data that's collected by the 100,000 Genomes Project will be kept in a secure data centre, and access will be into that data centre. Nothing will be downloaded and taken away, but I'll talk about that in a minute. And something that doesn't sometimes get really mentioned in all of our rhetoric is something like £20 million has been invested via Health Education England into improve training and development of the workforce. That includes everything from online courses through to trainees in bioinformatics at a PhD level. So there's a lot of programs going on in health education to develop a workforce that's much more familiar and confident in genomics. And then I'll talk about these again in a minute, but we have this concept of clinical interpretation partnerships, which is where the researchers come together in collaborative domains to access the data, to access funding from other funders, to really try and drive the discoveries faster than you might get through individual access requests. And that's where we think the bulk of the additional funding from the MRC and the Wellcome Trust, and hopefully the Cancer Research UK will come in time. I've talked about these partnerships, but I think I would just like to come back to some of the comments that were made by the previous speakers, is they are very much partnerships with industry. It's not where industry is just a contractor, but we are expecting to be able to be partnerships, most particularly with Illumina, who are a fundamental part of this, but they're a partner, not a contractor. And this is a very complicated schematic of how all the various bits work together, which I've sort of just used to summarise now. But the NHS is responsible for all of the clinically facing aspects of the project, both in terms of recruiting the patient, accessing the patient record data at the actual phenotypic stage, providing the samples, both omics samples and DNA samples, and the consent. And then at the end of that process, they're also responsible for giving the feedback to the patient and for their continuing care. We have a good partnership already with the Biocentre, which is where all the samples are stored in a secure storage, very much as Rory explained. They're then sent to Illumina for sequencing, and the data then comes back into the Genomics England data centre, where it is made available for the interpretation, the really quite complex interpretation, and then anonymised as well to make it available for researchers and for industry. And those are quite important elements. So in effect, we have two data sets. One is the patient identifiable data, the clinical data, but that's completely separate from the genomic data, which is non-identifiable. And then on the right-hand side, we have a number of other links and partnerships with existing data sets, which is the cancer registry and the new rare disease registry data. And we have a lot of work going on, as it says down there, on the data analysis and improvement, to actually understand and build better tools to get to understand, interpret the data better, and also providing a service to evaluate different providers of tools and data sets and so on. And this is a process that was coined by one of the companies that we first met, called a bake-off. So we have a series of bake-offs, and these are ways of actually trying to get companies able to demonstrate their wares, and if they're good, hopefully we can provide access to the data on a contractual basis, which would be another key revenue stream for very small spin-out companies. So just from a patient's perspective, in trying to simplify this is the way the system works. So we have patients at the very heart of this, at the top, giving their consent. All the data is collected, sequenced, interpreted by a combination of Genomics England's own interpretation providers, but also hopefully in time by the academics who access this data, and by the industry users themselves, because all of the data that's accessed, interpreted and used should be fed back into the knowledge base, as we call it, so that we can improve the reports given to clinicians, who can then in turn feed that back to improve patient care. So the whole thing is hopefully a kind of ecosystem which delivers excellent patient care and excellent science. We have so far been working flat out, I think the team have. I feel like I've been tagging along very much, but the team has been working flat out and getting some fantastic partnerships going, as I said, with some of the key parts of this. The NHS are now fully running, all the centres are enrolling patients. We have a brand new building on the top, I think it's the lower floor of the building, the new building at the Sanger Centre is dedicated to the Genomics England sequencing capacity. There's a secure data centre. Notice it's not named as to where that is, but it's a very boring building in a very secure environment. And we have a minister looking at a robot in the bioresource. So it's all there now, all ready to run. The genomics centres, medicine centres are now all established. We have a complete jigsaw covering England. Notice it's England only at this stage, but we have 13 GMCs covering the whole of England. And we're also very happy to be able to start working with some of the other countries who have accessed funding from their own fund sources and also from the MRC to provide them with a capacity to feed patients into the 100,000 Genomes project. So Northern Ireland are hoping to start recruiting patients this year. Scotland not far behind, but with quite a different approach because they'll have their own capacity in Edinburgh and Glasgow to do sequencing. And Wales, having now had the election in Wales, they are now moving fast to do their project. So over time, this will become much more of a UK project. But please don't ask me to change the logo because we've said no, we're not going to change the logo from Genomics England. We'll have to just fudge that one. And I think one of the key aspects, as I said before, that I'll come on to talk about in a minute, is that we have to be honest with patients about what they will get out of this, patients and participants, because I think it's worth reflecting, and I always have to do the maths again, is that we're talking about rare diseases and cancer, and we're talking about 100,000 whole genomes, but we're not talking about 50,000 patients from each. Because the way this works is that patients are recruited when they come to a clinic with a relevant rare disease. We're talking about probands or patients, maybe there's a child, and we're talking about sequencing in rare diseases, sequencing trios of at least one patient and at least one unaffected relative. Probably in the most likely scenario we seem to be seeing now is an affected child and both parents, and that's what we're really looking to sequence, a trio there. So we in effect have 17,000 rare disease patients roughly, around about 34,000 healthy parents or ostensibly healthy parents or unaffected relatives. And then in the cancer, it's 2 sequences per patient, so it's 25,000 patients. So it's a resource that's a combination of people with rare diseases, many of which might be de novo, and parents who might be otherwise healthy. So there's quite a rich resource. It isn't just about affected people, it's about a healthy combination. It's not as big as the UK Biobank, but they are sequenced at much greater depth and will have, I think, hopefully useful clinical value, scientific value. We're going to give them back information about their main condition. So if we find anything in the reports, and the hopes are that the diagnostic yield, as it's called in rare diseases, could be as high as 50%. So hopefully a lot of those patients will get told roughly what's wrong with them. Whether there's a treatment or not is difficult to say, but there may be a trial they could be enrolled on. We're going to give them also, potentially offer an opt-out consent for particularly the healthy parents or other the affected people if relevant, to get given information about serious and actionable conditions. And this is quite an interesting area for the ethical discussions, because these are conditions that are widely understood in families with rare diseases. We think we know enough about the conditions to actually offer feedback that says you might want to think about enhanced screening for cancer, or maybe there's a risk of familial hypercholesterolemia, for example, with high blood cholesterol that can be treated with statins. So these are really actionable findings. They're not going to be giving people information they can't get some sort of benefit from. And that's just about all we're going to give them back. There is another more complicated scenario if we find that parents of an affected child themselves are carriers for a serious condition. I don't know that that's actually been tested in practice yet, but it's again an example that might be within that category, that given that the NHS is well used to providing a kind of free at the point of delivery service that gives people information about their risks and so on, we can actually offer this carrier status feedback in a way that other healthcare systems might be more challenged by. But I think it will be, again, very interesting to evaluate all of these experiences at the end of the project. And on that note, we are very keen to make sure there is strong patient and public involvement in the projects. Each of the GMCs is expected to have its own patient and public involvement. Each of the GSIPs has its own patient and public involvement component to it, as with a normal research-funded project. And we also have started to establish a national participants panel where people who are participants are invited to join a meeting, and they also then provide us with a fantastic resource to go and help to make sure that our committees and our various governance structures have an understanding of the patient experience themselves. So we have just welcomed a number of members of the participant panel onto the Access Review Committee, which is chaired by Jonathan Knowles, and is the main committee that dictates access or not to the data centre. So I think this is a really important benefit. Just to summarise, and it's a very busy slide, just a couple of those points. We are very focused on making this a transparent, ethically transparent project with a very detailed consent process. I think that's been quite an interesting challenge to do that against a backdrop of expecting to have 100,000 genomes in 3 to 5 years, because getting the research approval right, getting the patient literature right, is an ongoing task, and these documents are constantly being improved and rewritten, but they are really important that we have a wide range of documents for all age groups, and also including people who may not have capacity, so that we can get a really a consent-based study. I think on top of that, we will also be doing work increasingly about patient and public engagement. And I think there's two components of that, coming back to Natalie's excellent talk this morning. Two components really is, one is actually focusing on the, as it says here from the original announcement, on public communication to address the aspirations and concerns of the wider public. And often that means as much as saying, well, this is not a project about you because you're healthy and these are patients and so on. But also have a dialogue with patients about what they expect from the NHS in the future and how the NHS needs to capitalise on genomics to improve the health of patients. So it's a really two aspects to this engagement effort, which is being led by Viv Parry and Katrina Nevin-Ridley at Genomics England. And I think it's really important that we try and involve as many people as possible. So coming back to something I touched on earlier, in one of the original working groups chaired by Mike Parker, I looked at this again a few months back because I think it's an interesting example of circularity, which I'm hoping this conference can help us address. Mike's working group recommended to the CMO a series of core principles and priority actions, and I've sort of aligned them here. It's a bit too detailed to read into, but really it's about trying to make sure that the project itself has a kind of ethical framework to it around benefits to the patient and the NHS, giving feedback to the NHS to drive improved care, being transparent about data access arrangements, and focusing on consent and having a public engagement campaign. So all of those things were set out, and I think, I guess I should have put this slide up front really, but all of these things were set out in 2013, and many of them are being delivered here. But I think the most important one to get right, and I'll touch on this where we are so far, is around the priority action on the benefit, a clear policy on commercialisation, detailing the extent of data sharing, IP, and what oversight will be put in place to ensure that the commercialisation is in the public interest and brings benefit to the NHS. So I think that's almost what this workshop, so this conference is about, actually, I think. So it's actually nice that Mike has followed up on what he first recommended, because as I was saying, I'm a big fan of open policy making in this regard, because I don't think Whitehall can be expected to get this absolutely right and balance off all these various interests. So I don't really have the answer to that thing, but I can explain a little bit about what's happening so far. The first I've already talked about a bit, which is on the Genomics England clinical interpretation partnerships. And this is quite interesting because there are now something like 2,500, I think, researchers signed up to be a member of a GCIP. I was speaking to one at Coffee as well, actually. They're designed to become collaborative ventures to make sure that we don't have too much competition between different academic teams looking at the data, to make sure that we can also feed the data back into the knowledge base and to improve the strength of this data set, and also to allow us to forge better partnerships to spin out some of these benefits into companies that can start to derive improved diagnostics or therapies. So that's a sort of a snapshot of where the academic involvement will be. And I think one of the important things is where we can't make a diagnosis, for example, a rare disease family, the idea would be that this then effectively becomes like a crowdsourced problem for the academics to start to research and look into. And then hopefully in time that gives us enough of knowledge to tip an example of a possible relevant mutation, it becoming something that's clinically relevant and can be fed back to patients. So we have to sort of explain to patients they might not get a result in the first report they get, but they might well be results that come later down the line through research. And I think this is something that rare disease patients are quite familiar with. Certainly going back a few years before the Human Genome Project, it was quite common to be part of a research study and to get a diagnosis eventually through that route. So I think hopefully it's part of that benefit to the NHS, which will accrue over a number of years. And then a more interesting example, I think, given the relevance to this talk, to this conference, is around the work, the partnership with industry so far. So leaving aside all the various commercial partnerships there are, like Illumina, all of the clinical interpretation is done pretty much by commercial companies operating under contract. I think that includes Guild's company. So I think we have small spin-out companies and larger companies providing the services. But what we really hear about is getting companies to come together in a pre-competitive consortium, which is summarised as the Gene Consortium, to look at the data that we are developing so far through the pilots, to look at the data tools that will be provided in this secure data infrastructure, and to then see if there are opportunities for companies to work with the data to support them in how they might use the genomic data in discovery. I think we're also hoping to train a whole new group of people in industry that are not used to looking at genomic data to actually understand the benefits of genomic data. And I think the important thing is it's only a trial at this stage. It's a 1-year-long industry trial. Different companies have put different amounts of funding into this consortium depending on the size of the company, and so smaller companies put less in. And I think what we're now seeing is how these companies can work together collaboratively. Ultimately, I think there'll be other access arrangements which are done more exclusively, where particular companies are interested in particular disease groups. And again, each one of those will become a bit of a trial. We're sort of having to sort of build this aeroplane while it's in flight to actually see how it best works with companies. But I think the important thing is we have all of these various ethical frameworks that I mentioned before to guide it. And the Access Review Committee is interesting. The Access Review Committee that I support at Genomics England is very much now coming down to asking the same question of everybody who wants access to data: is how will this improve patient access? How will this improve the patient experience? How quickly can you get patient benefit through accessing the data? And that becomes the kind of key test for any company coming in. Backing that up as well, and I haven't got it in any slides with hindsight, we have a very long and detailed policy on acceptable uses. And there are quite a few uses that I haven't heard mentioned today which are deemed to be unacceptable. Insurance is one of them, which has been mentioned already. But we also have got quite clear undertakings from the chief police officers that they will not seek to access the data. We've got examples where, child support, custody cases, all of those things, the data is simply not allowed to be accessed by government or by individuals, even if they know that they kind of have potentially useful information there. We are really going to be quite strict at policing those. And there's some very interesting conversations already starting to happen with the Information Commission's office about how we can make maximum use of the protections in the Data Protection Act. So I think all of these things will be important to get the experience of and then be transparent about, and hopefully then through groups like this actually really be challenged and to see whether this is best practice and what policy changes might be needed longer term. And then finally, I think one of the things that I've heard mentioned in the earlier talks this morning is what we're trying to do here, and characterised by Sir John Chisholm, of saying moving away from, certainly in rare diseases, moving away from a sort of cottage industry and a craftsmanship approach of how different phenotypes like joined together fingers and toes are described, moving away from kind of lists of candidate mutations and how they're interpreted by experts into something that's just much more of a pipeline, a commercialised pipeline. And I think you probably can't read this, I'm certainly struggling here, but some of the pipeline here, particularly these bits in the middle, are very much going to be done by small companies that are experts at interpreting sequence data, that got their own proprietary data sets they've brought together using a combination of expertise and collaboration. And this is the bit of the pipeline that we really do want to see industry providing. This is a platform for those industries to develop their wares. Because at the end of the day, I think we must recognise that 100,000 genomes is a lot. But if you look at the sort of total of the potential for genomic medicine in healthcare across the whole world, it's a huge potential opportunity for companies to start to develop a whole new service that doesn't exist yet. And I think that's one of the most important things that we have to be really open and honest about coming out of this project. And then I'll just wrap up finally just to say this is the slide that everyone expected to show. This is the kind of ticker counter which has effectively been stopped because of the pre-referendum period. It's as you can see, it's tantalisingly close to 4 figures. It's actually over 4 figures now, but we're not publicly announcing that. And I think really what this is showing is, although we are quite a long way into this project, it is picking up speed rapidly. And I think we're just incredibly grateful to everyone, particularly patients, but also all the researchers, the academics, and everyone who's been working hard to get this far. And I hope the next 90,000 are a lot easier than the first 10,000. So thank you very much.